Okay, then welcome everyone. Actually, today's class, there was some misunderstanding in the previous class itself that I've explained about the assignments of this class in the previous video. So I'll be going through a brief of this last week's assignments and for this week assignment. So it will be a slightly a longer class. So here first we'll be discussing the assignment number 10, which is from the previous class. So I will be giving you the explanation for some of the problems from the previous assignment if you have not yet submitted them. So this is the interactive live session number 10. So here we go. So we have the first question. The lap or sandwich test is commonly used to evaluate the dash strength of the polymer joints or bonded structures. So here you can see there are different types of uh, joints, lap joints, or you can also call the sandwich joints, which are present right here. So let's analyze what kind of property they are trying to test here. Okay. So going from the first one itself, as you can see, we have the single lap joint. Okay. In single lap joint, you can see that two pieces are joined together and stuck at one of the ends. And then at the double lap joint, you can see that on double side in the double sided portion, the single sided portion is stuck in the middle right here. So you can call this the sandwich test also. So you can see it looks like a sandwich as the one of the portion of the material is being sandwiched between the two other portions. And similarly, we have the double butt lap joint. So you can see the blue marking in the middle. That is how the lap joint is made. And then beveled one and the joggle lap also. So whenever the force is being applied in the tensile format, as you can see, both the ends are going apart. So in this case, we are trying to find out what is the strength of this particular joint in the middle. So the lap test or the sandwich tests are basically used to test the strength of the polymer joints or bonded structures right in the middle. And this is used to determine the shearing effect inside the polymer itself under tensile forces. So when the forces are being applied, the tension is being generated inside the body, and the resistance to that force will be exactly in the center of the joint right here. So because of that resistance in the center, uh, as we all know that shearing force is applied. For example, if you were to consider a rectangular shape and if you were to apply the shear on the top of it, so the entire rectangle will start shifting from the top in that direction. So it looks something like this. Like if you have a square of four equal sides, and if you were to apply the shear or the force on top of it, so it will start shifting in the direction of the force from the top. So similar kind of effect is observed in all of the lap joints, and that's why shearing force or the shear strength of the polymer joints or bonded structures is measured using the lap or the sandwich test. Moving on to the next question. The Charpy and ISOT tests are commonly used to measure what properties of the material. So here we have the schematics of an ISOT test and a Charpy test. So for the ISO test, the what should I say now? The main distinguishing factor between the Charpy and the ISO is that how the specimens are being handled in that. So as you can see in the ISO, the pendulum or the hammer is striking the material which is standing in the vertical manner, and the notch is being present at the middle part of it. So that is the notched area, and we are testing the material in the vertical manner, and the pendulum hits the top portion and it will start breaking from the notch itself. So the hammer or the pendulum, when it is coming and striking the specimen itself, this kind of force which is being imparted on the material is called the impact force. So we are commonly measuring the impact properties of material using this. That is basically impact force or impact energy. Similarly, in chart P, you can see that the material is kept horizontal and the notch is being made in the middle. So the notch is being made in the middle, and then the pendulum or the hammer comes down on top of it and then strikes at one end in the horizontal. direction. As you can see, it is tracking right in the middle where the notch is present, and it will break at that point. So that is the basic distinguishing factor between the IZOD and the Charpy. And then the scales are also different in the IZOD apparatus and the Charpy apparatus, and based on that, your impact properties of the material are calculated. Next we have is polarization optical testing is commonly used to analyze which property of the polymeric materials. So we have been given four properties, and basically polarization optical testing uh, is basically done so that we can measure the change in polarization of the material, change in polarization of the light because of the material's properties. So, to analyze the polymeric materials are very well known to cause birefringence. Now, what is birefringence? In birefringence, or you can call it double refraction, whenever the light is passed through a polymer, because of their conformation or the molecular chain structure, they refract the light into two components. So basically, that's how it is. So birefringence is caused because of the internal stress or the molecular orientation of the polymer molecule or the chains. So change in polarization. For example, you can see right here, the light goes in and the refringent or the polarized light comes out. Birefringence is happening, and because of that, two streams of light are coming out. So that is called the polarization, and both the polarization factors are parallel and perpendicular in nature. For example, if your light is coming in at a certain angle, from with respect to that angle, it will be differentiated into parallel and perpendicular sections. So, birefringence is the answer for this question. Polarization optical testing is commonly used to analyze the birefringence pattern of the polymeric material. Next, we have FTIR testing is commonly used to analyze which of the following properties of transparent polymers. So, FTIR is basically the Fourier transform infrared spectroscopy, and it is usually used to test the transparent polymers. And the property which is being shown by the FTIR testing is the chemical composition of the respective polymers. How that is done is you can see right here on the x-axis we have a parameter called the wave number. So all all the light spectrum has a specific wavelength for a particular light pattern. So with respect to that, with respect to that, we are testing the chemical composition of the polymer itself. And how does that happen is, you can see right here, we have the wave number going from 500 to 4000. And we already know that infrared region lies way beyond the 700 nanometer range. Or the wave number is basically the inverse of your wavelength. So you can see right here. So we have the different regions of different functional groups and how they are being exhibited. So there are two types of exhibitions by the bond itself. First is the stretching and the vibrating frequency. So what happens in these regions is that your bonds might stretch back and forth, or else if they are in one place, the bond length might change a bit. That is called stretching. And vibration means when the bonds are vibrating in one single place itself. So that is exactly what is meant by the vibrating parts of the bond and the bond stretching itself. And you can see that particular wave numbers are signifying the particular functional groups which will be observed in that. So in the blue color, we have the spectrum of some material, and you can see right here that C single bond O, C N, C C, C double bond O, C double bond C, and C double bond N are being observed in the 1000 and 1000 cm inverse range. And then nitrile carbines and CH stretch, OHNH stretches can be seen from starting from 2000 to 3500. So these are some of the chemical functional groups which can be identified, which can be used to probe into the structure of the transparent polymers. So chemical composition can be easily identified using the FTIR technique. Next we have Which apparatus is commonly used to measure the optical properties of polymeric materials? So we have been given right here four properties, four measuring uh, procedures. First, we have the UV vis spectrophotometer, scanning electron microscope, X-ray diffractometer, and differential scanning calorimetry. So among these, we can clearly see that the UV vis spectrophotometer is used to measure, since the word photo is present inside that, it is used to measure the light changing light changing or the photometer to observe the intensity of the light being refracted, reflected, or any other parameter like that. And then we have the scanning electron microscope. Scanning electron microscope uses an electron beam to illuminate the polymer samples and the intricacies of it at the uh, nanometer scale level or the micrometer scale level. And similarly, we have the X-ray diffractometer. X-ray diffractometers are used to measure the uh, crystallinity of a particular polymer or the crystalline arrangement of the polymeric chains. So that is being observed using the X-ray diffractometer. Then we have the differential scanning calorimetry. Scanning calorimetry is used to observe the calorific value of the polymeric materials and what are the different types of temperatures, such as the glass transition temperature, melting, crystallization, and decomposition. Temperatures which can be observed for a typical semi-crystalline polymer can be studied using the differential scanning calorimeter. So the first one is the UV visible spectrophotometer. You can see right here, till the 700 nanometer region, the red wavelength is there. And beyond this part, you have the infrared, which is being used by the FTIR or the IR spectroscopy method. Below these, specifically below the red, that is 6685 or 630 nanometer, all the way till 400 nanometer, and sometimes even below that. In this region, you will have the ultraviolet visible light spectrophotometry occurring. So this is the region, or this is the wavelength region which probes the optical properties of polymeric materials using this. And why is that? Because since these wavelengths are basically more powerful and they can pass through the polymeric material itself, whereas the infrared or the redshifted wavelengths, which go beyond the 665 nanometer, are often scattered because of the molecular interactions. And that's exactly the reason why FDR is able to tell you what is the chemical composition of the material. Then we have the last question. Which of the following methods is commonly used to measure the diffractive index of a polymeric material? So, spectroscopy, we have just seen that spectroscopy is used for measuring the infrared properties and, sorry, not infrared property, that is the chemical composition of the polymer itself. And then interferometry and polarimetry are also some of the other ways to measure the similar properties of the polymeric material, which tells us about the conformation of the chains and how they are able to polarize the light itself. And to measure the refractive index of polymeric materials for thin films, ellipsometry is being used. So ellipsometry is the answer for this question. And we can see a small apparatus for the ellipsometry. As you can see right here, we have the light source which is unpolarized, and then we have a polarizer which polarizes the light beam itself, and then it passes through a compensator and it is striking the sample right here. And you can see that the angle at which it is striking, the same incident angle is being seen in the reflection of the light itself. And the plane of incidence you can see right here. Then it passes through the compensator again. Then we have the analyzer and a detector. So you can see that we have different polarizations right here, perpendicular and the parallel polarizations, which can be then observed by the detector to observe how the light is being refracted by the material. And that's how you are measuring the refractive index of the polymeric material and the uh, refractive index of the polymeric material, which is caused because of the polarization of the light itself. So these were the questions for the last week's class. And for the today's class, we can see a few questions right here. So in electronics, polyurethane-based conformal coatings are primarily used for which purpose? So we have four. So in electronics, polyurethane-based conformal coatings are primarily used for which purpose? So we have the enhancing electrical conductivity, preventing corrosion, increasing mechanical strength, improving optical clarity. So polyurethane-based conformal coatings, as you can see in the illustration right here, the machine is applying the blue colored coating on top of the green colored printed circuit board. As you can see these conformal coatings, the aim of these conformal coatings is to prevent any kind of moisture or any kind of material which can cause corrosive effect on top of the printed circuit board and to avoid any kind of dust or any kind of dust or any kind of foreign particles to uh, deposit upon the printed circuit board. So because of which corrosion can happen. Basically, it is used for preventing the corrosion itself. So enhancing electrical conductivity is a parameter which we are not looking for. Increasing mechanical strength and improving optical uh, optical clarity are not the parameters which are concerned with the printed circuit boards or the electronics. So prevention of corrosion. What is the primary advantage of using epoxies in construction and manufacturing? Basically, epoxy groups are very useful when compared to other classes of resins such as the USP resins, which are nothing but your unsaturated polyester resins. Why? Because epoxies are basically having higher mechanical properties and they are used in all of the advanced polymer composites. So that's why epoxy polymers are used in construction and manufacturing because they are basically high-end epoxies and the main parameters which we are looking for when using epoxies is high resistance to heat and chemicals. And on top of that, their mechanical properties are much better than the other resins. High electrical conductivity, rapid curing time, low cost compared to other adhesives are not the properties of epoxy because epoxies take uh, a good amount of time to cure and they are not low cost. They are pretty high cost. Which of the following properties is associated with the Novolac resins? So, for the Novolac resins, what are the main properties which are a basic focus is that Novolac resins, whenever they are burnt or whenever they come across any situation where the temperatures are high and they spontaneously catch fire, or any kind of flaming agent is there to cause the fire on top of it, because of a mechanism called the char formation they have the excellent tendency to retard the flame which can spread on top of them. So basically, they have excellent flame retardancy feature. Okay. So epoxy phenol novolac resins are very good at dissipating the
Excuse me, sir. So
yeah.
actually, the slides are not moving, sir.
Oh,
Uh,
okay. Okay. Sorry. 1 second.
yeah.
Is it visible now? Yeah, I think now it should be visible, right? Reshmi, is it visible now? I hope it should be visible.
Yeah, it is visible, sir.
Yeah, okay. So, yeah, I'm sorry. Actually, I didn't change the presentation mode at that time. So, yeah. So, this was the one which I was trying to explain. The illustration for the polyurethane based conformal coating. You can see right here. And it is basically used for prevention of corrosion as it stops from any kind of foreign particles to enter inside the printed circuit board. It will not improve optical clarity because we don't have any need for optical clarity in electronics. And then increasing mechanical strength is not the purpose, and enhancing electrical conductivity is definitely not something which we want. So prevention of corrosion is the property which we are looking for. Then we have what is the primary advantage of using epoxies in construction and manufacturing. As I told you that epoxies are basically high strength materials and they perform better than any other.
The next
Uh,
slide, sir.
Next slide, right? This one or this one?
Yeah,
No.
that's it. Oh, it is not moving, sir. It is in the same polyurethane.
Oh,
Yeah.
now it has moved, right?
Mhm. Now it has come to Novelak.
Oh, okay. Now is it an epoxy?
Yeah. It is an epoxy.
Okay. I think because of the animation, it is taking a lot of time to move around. Okay.
Yeah, maybe the delay is coming. Say, okay, fine.
Yeah. So the advantage of using epoxies in construction and manufacturing is that it has high resistance to heat and chemicals. It is chemically really inert. And one second. It is chemically inert and it has high resistance to heat. On top of that, rapid curing time is something which we are not looking for in epoxies because epoxies will take a lot of time to cure, and they are definitely not low cost because they are one of the high-end advanced polymer composite epoxies. That's all. And as I explained for the Novolac resins are used because they have the ability to form char. They have a charring effect, and because of this formation of char, they help in preventing the spread of flame any further. So that's why they have the excellent flame retardancy features. Then next we have fluorinated acrylic coatings find application in electronics for their rich property. So we have been given four property right here. Electrical conductivity, then we have the thermal insulation properties, corrosion protection, and the moisture resistance, optical transparency, and light diffusion. So fluorination process, as you can see in illustration right here, is basically what does the fluorination process does is that it reduces the surface energy of any material. So because of that reduction in surface energy, all water droplets or any kind of moisture, it simply is removed. So this removal of moisture creates a very good moisture resistance. And since the C and F CF bond is that is the carbon fluorine bond is very strong, it prevents any kind of further water to come on top of the polymer surface. And because of this, the corrosion is prevented. So corrosion protection and moisture resistance are the main features of the fluorinated acrylic coatings. Then we have polyimides are commonly used in applications requiring which property. So polyimides, once a schematic of the polyimide is shown right here, R1 and R2. We have the nitrogen and two double bonded oxygens right here. So polyimides are basically used in the industries to provide high strength and rigidity. So they are the main parameters which we are looking for when using the polyimides. Next, we have the polyxylenes or parylene are commonly used in electronics for which of their properties. So apart from the polyurethane coatings, which we saw in the first question, parylene are also used. And what do the paralenes do is that, as I said in the first question, that high electrical conductivity is a feature
So
which
excuse me, sir. That the polyamides, no, it is a
Hmm.
UV resistant also, no?
uh, not exactly UV resistant. It will react to the UV also. Polyimides, not
Oh,
exactly
okay.
because UV in basic like UV basically affects all of the polymer materials because some to some degree it won't affect for acrylic also it is optically clear, but still UV also affects it for long term any kind of long term exposure to that, so UV will be affecting that.
Okay.
Yeah. So high strength and rigidity are one of the best qualities of polyimides, and that's why we are using them. Then, in case of parylene, the main parameter with, for which we are using the parylene or the paraxylene is that it has low dielectric constant. Now, because of this low dielectric constant, they are used in the electronics so that any kind of conductivity does not occur on top of the printed circuit boards or any kind of electrical circuitry because any kind of unwanted conduction can short circuit the entire printed circuit board or any kind of material. That's why we are using the low dielectric constant material such as the paraxylene. And last we have silicones are commonly used in electronics for thermal management and electrical insulation applications. So silicone and the one of the most popular products formed from the silicone itself is the polydimethyl siloxane. They are used in electronics for thermal management because uh, they are good heat insulators. So, sorry, heat conductors. They can be used for heating or cooling down as a heating oil itself. Then the electrical insulation applications, they are excellent dielectrics. They have good dielectrical properties. So that is the exact reason why silicones are commonly used in electronics for thermal management and electrical insulation applications. So it is true. So I or like for anyone who has joined new right now, these questions were already discussed in the last session itself, but apparently the assignment for which these questions are, its deadlines are in this week itself. So that's why I'm just showing these questions once more. So if you have any doubts, you can ask me.
Actually, in the last assignment, no, there was a question which had the lab shear, no, that
Hmm.
is, they were asking which type of force is applied.
Hmm. Yeah.
So the type of force we applied over the lab shear is tensile only, no, sir,
Yeah.
because
That.
we through tensile we need to have a shear.
Hmm. Correct.
So, but in the answer key which has come, no, they have given tensile as the answer. So that I had a doubt because shear is happening, but the force applied will be tensile. That's my understanding from the course.
Correct. Yes.
But my assignment, when I my for me, it was given 0 marks was given for the tensile answer. So I had a doubt. Okay,
So what
so
was
I
the
didn't.
correct? So what was the correct answer for that?
Shear, sir.
Shear, right? I think.
Which force is used to create a shear? Shear. It was asked.
Okay. No,
So
I
I think
think.
this that was the first question, sir.
Okay. I'll just open the first question. One sec.
Not here, sir. Assignment first question.
Okay. Yeah, I think it was this one only. I'll show you. This one, right? Was it this one? Yeah, this it has to be this one.
No, no. This is here. It is evaluate the shear strength. That is correct.
Hmm.
But it was asked which force. I think, sir.
Which force? I mean, basically,
Uh,
yeah, I mean, we are seeing the shear force only. That is the right answer for this. We are
no, we are
using.
seeing the shear. Let me open that assignment. And also one more thing was there, which is the age? What is the standard which is used? That was one of the question.
Hmm.
And of course, we were having the understanding of ACE only. But in the course, it was told that for fluctual strength and ISO is the best method. Specifically, it was mentioned in the class.
Actually, even in our lab and sometimes in some other places also, we use ASTMs also and ISO, so both of them. So I'm not sure how may I, like how can I specifically answer for that because both,
Because we all it's in random, no, when we answered we
yeah.
had answered in this HTM only, but after that when we went through the course, no,
Hmm.
we had an understanding that it is ISO, and we all means we had changed our answer also, but unfortunately when the answer key came, no, again it was HTM only. But in the question, no, it was because when the question was given, no, it was clearly sorry, when the note was given, no, it was clearly told that ISO is a standard which is followed for fluctual.
Hmm.
So
Okay.
that confusion also had come. So as a assignment question, so the question was the lab or sandwich test involves
Hmm.
bonding two polymer specimen together and applying a dash load to induce shear stress.
Okay.
So
So
load can be tensile only,
yeah,
So
load
I
should be
don't know.
tensile only. So the answer was tensile or
So
shear?
no, no, shear, sir, because 0 marks is granted. So which means that it is written shear is the answer.
I mean, uh, yeah, if the kind of force we are trying to apply is shear, because today itself I performed a shear test in my lab. So the standard which we followed was ASTM D732. So in
Yeah,
that,
yeah.
what happens is that we are applying force from the top, and the material is sheared in the Z direction, not in the X
As a
and Y.
top, but top we are giving tensile load only, no?
Yeah, that also can be done. As you can see the illustration in this picture, we are applying tensile force only. You can see these two ends are going in
Okay.
different directions. So
Yeah.
basically, we are
So that's what
producing.
sir. So
Hmm.
that's why I understand. Here the answer should be which load means it is a tensile load. I think that answer will be tensile.
Yeah, you can say in
We
one
didn't.
way that, yeah, if you are testing the lap joint or the sandwich test, definitely tensile load is being applied to create the shear. So that would be right.
Yeah, sir. Yes, sir. So that answer, no answer key was
Hmm.
shear, sir. So
I'll do one thing. I'll ask sir about
yeah.
what should be done with
So
that
kindly, if
because,
there is any correction, no, you can kindly relook into that evaluation, sir.
yeah, sure. I'll try to do that.
Regarding that ISO and ASTM also. In the lecture class, it was specifically mentioned that ISO is a standard much better than ASTM. It was told in the lecture class. Okay,
Okay. Uh, okay,
with
sure. I'll
respect
try
to
to.
fluxus, that
Okay,
also was there.
with respect to flexural properties. Okay, sure.
So for
I mean,
a
huh,
for a tensile, I am having a same doubt.
hmm,
But in case of ASTM and ISO, so
yeah,
moreover they are more considering ASTM because ASTM is adopted everywhere. There are
yes,
many countries they don't accept ISO, but they
ISO.
accept ASTM.
Exactly. Even we in
Yes,
our lab,
exactly,
we
sir. My
use
understanding
ASTM
also.
only.
Yeah, my understanding is also like that only. But in the class, no, in the lecture
Hmm,
course which was given, no, in that
hmm.
it is specifically written that for the fluxural it is ISO. That's why we had a doubt.
Okay, okay. Okay, then I will ask sir about this. What can be done? Because even I think that ASTM is better. Even in my lab, till now I'm using ASTM test standards only. ISO
Yes,
is
yes,
like
means, me too doing the analysis. We also follow the ISO, sorry, ASTM only. So since the
ASTM only,
class
right?
delivered like that, no, we gave the
Hmm.
ISO as the answer. Okay.
Okay. Reshmi, you are joining this class from the last session only, or have you joined before also?
Yeah, before also I have come, sir.
Okay. Okay. So yeah, I'll just ask sir about this. What should be done about that part? Okay. So yeah. So I'll just recap the few questions for which were like shown in the last class itself. Lap or sandwich test is commonly used to evaluate which force, and as we can see from the description and the illustration itself, shear forces. And then Charpy and Azure tests are commonly used to measure the properties of which materials, like which property of the materials, that is the impact properties. You can see right here how the notch is being made right here, and the specimen is being striked upon in Izod and the Charpy test. In Izod, the sample is standing vertical, and in Izod, it is kept horizontal, the notch, and the hammer or the pendulum when it strikes, the impact properties of the material are tested as we can see the reading on the scale itself. Then polarization optical testing is commonly used to analyze the birefringence property of the polymeric materials. So the birefringence property of the polymeric material occurs because of the change in polarization, and whenever the light is any kind of light is passed through a polymer, sometimes what happens is that it causes birefringence, that is double refraction. And because of this double refraction, the light is changing its polarities in perpendicular and parallel directions. And because of that, there is double refraction. So this double refraction is called birefringence. And this birefringence is measured using the polarization optical testing apparatus. Then Fourier transform infrared testing is commonly used to analyze which of the following properties of transparent polymers. So
Sir, slides are not changing.
slides are not changing.
Now it happened yet, but previous slide of polarity, it was like stuck on a chappy one.
Oh, okay, okay. You can see this is the polarization.
Yes, sir. Yes, now it's
Okay. So this is exactly how birefringence works. You put in the sample, you send the light inside, and then out comes the light, which is polarized, and it is polarized in the parallel and perpendicular direction. And why does this happen is because of the internal stress inside the material or the molecular orientation of the polymer chains, which changes the polarization of light in two different directions. Then next, coming on to the FTIR. And in FTIR, what happens is that since it is infrared, we are looking at the wave number above 700. So you can see from the right hand side to the left hand side on the x-axis, it is starting from 500 all the way to 4000. So all the different functional groups which can be present inside a polymer. You can see right here the fingerprint region or the skeletal vibrations. Skeletal vibration means that every polymer has a polymer backbone. We know that. And every other functional group is attached to the polymer backbone. So because of that, what happens is that it creates a fingerprint region. This fingerprint region is unique to every polymer. So because of this, 500 to 1500, this region is very specific to every other polymer. And then after that point, we have double bonds and triple bonds, and bond stretching is also there. So in the infrared spectroscopy, whenever you're probing the molecule using the infrared, what happens is that the light can either stretch the bond or vibrate the bond because of the infrared uh, light frequency. So that kind of measurement can be made using that. So in the stretching, we have the OH, NH stretch and the CH stretch, which can be seen right here. And then we have the nitrile and carbenes, that is the triple bonds, that is C triple bond N and C triple bond O. And we have the C double bond O, C double bond C, and C double bond N right here at the double bond section, where the uh, bending of your bonds can occur. That is the bending and rocking. Rocking of the bond means basically vibration of the bonds. So rocking, bending, and stretching. These are the types of uh, polymer chain movements you can see, polymer bond movements you can see through using the FTIR spectroscopy. So by this, you can observe the chemical composition of the polymer molecule, and you can have some idea about what kind of polymer molecule it is and what are the functional groups which might be present inside. Next, we have which apparatus is commonly used to measure the optical properties of polymeric material. So amongst the procedures which are listed right here, differential scanning calorimetry is used to observe the temperature related variations in the polymer, and we can observe the glass transition temperature, melting, crystallization, and decomposition. And then X-ray diffractometer is used to measure the crystalline arrangement of the polymeric chains and observe the crystallinity of a material. And then scanning electron microscopy is used to observe the microscale surface phenomena or surface image images or any kind of undulations of the morphology at that kind of scale, microscale and nanoscale. And then UV vis spectrophotometer is the one which is used to measure the optical properties of polymer. Since we discussed in the last question about the infrared, and you can see the red wavelength going from 665 to 700. So below 700, whatever wavelengths are being used, they come under the UV visible spectrophotometer. So going from red, orange, yellow, green, blue. So these are the visible part of the spectrum, and then UV part starts from the blue wavelength. Going from blue to violet, we have the UV part. So that's why it's called UV and visible spectrum spectrophotometer. So optical properties of the materials are always being tested in these. And then we have the last question. Which of the following methods is commonly used to measure the refractive index of polymeric materials? Here, the illustration has been shown for the ellipsometry. Polarimetry and interferometry are used to check the polarization of the light itself and not the refractive index of the polymeric material. And spectroscopy, as we have seen, is used for probing the functional groups of the polymer and the polymeric material. So, ellipsometry is the procedure which we use for the refractive index of the polymeric materials. You can see the sample is being kept right here, and any kind of thin film or the polymeric material, when unpolarized light is polarized and hit the plane of when the light passes through the plane of incidence and it is detected. As you can see, P polarization and S polarization are recorded. That is the in plane and out of plane polarizations are recorded. And based on that, the refractive index of the polymeric material can be calculated. So these were the questions from the last class, last assignment. Few questions from the last assignment. So yes, if you have any doubts, you can ask me. These were like I just gave you a recap of whatever we have seen for anyone who came late to the class today. Prashant, sorry that in last class itself I had discussed few of the problems from the uh, this week's assignments because I wasn't aware of it and I mistook it for this week and then presented it last week itself. So that's why I gave a recap for all the questions which were shown in the last assignment section. So that's why.
Yes, sir. My last assignment was okay, but only the first question was get wrong. The tension with
Yeah,
this.
I think there is some kind of error. I will try to ask sir
Sir,
about
from
this.
today's presentation, the previous one, I missed the first slide. So can you share?
Which one? The shear strength one?
No, this is the previous week's assignment.
Huh.
During the starting, you shown us a presentation. That's one previous one.
Okay, okay. This one,
Yes,
right?
I missed the first one.
Okay. So the first one was in electronics, polyurethane-based conformal coatings are primarily uh, used for which purpose? So as you can see in the illustration right here, that the machine is coating on top of the printed circuit board. So this kind of coating is the polyurethane coating. And the main use for this is that it does not let any kind of moisture or any kind of foreign particles enter onto the printed circuit board. And that is basically done to prevent any kind of corrosion on the printed circuit board. So prevention of corrosion is what we are aiming for using the polyurethane conformal coatings.
Yes, sir. In industrial like DCS panel, the circuits boards are used
Hmm.
to just assess the life. We measure the corrosion rate because we have installed some another metals,
Yeah.
and we continuously measure temperature, relative humidity, as well
Hmm.
as corrosion factor of three different metals like ferrous, copper, and aurum.
Yeah.
So then we can estimate that our panels are in good shape or they are getting corroded.
Exactly. Exactly. Yeah. So I hope you don't have any doubts. I guess Reshmi and Prashant. So yes, today's class is over, I guess.
So,
And
so one second. So this year, this sorry, this week assignment. No, there is a
hmm,
question asking for which of the following encapsulation technique involving polyurethane is commonly used in electronic applications.
hmm,
And the options going for potting, molding, conformal coating, and dispensing.
hmm.
And to my understanding, potting, molding, and conformal coating, all the three goes for encapsulation, no, sir?
Yeah, all three will be used. But I think,
But in
yeah,
potting,
coating.
so only one option we can select from this, sir. So we
I guess conformal coating should be taken. That will be like,
okay, okay, okay.
hmm.
So that is the more apt encapsulation method, sir.
Yes, that will be more apt.
Okay.
So, what are the other encapsulation methods which they asked you in the exam? They have taught you.
Potting, molding, and conformal coating they have taught, sir.
Okay, coating is also done, right?
Likewise, as per my understanding, potting is just like creating a particular box in which you fit the
Fill
electronics.
the yeah,
Yes,
fill
Yeah,
the
yes,
yeah.
and in molding, according to shape, you will do, and in the third one, you just put inside everything and concealed it for a long
concealed.
lasting.
Yes. So that is exactly how these things are done. I guess conformal coating will be the one which matches it the most.
Okay. Okay.
Yes, because conformal coating is used on every product just because to increase its shelf life and avoid corrosion.
Hmm. Yes, exactly.
Okay, thank you, sir.
Yeah,
Yeah, thank you. Thank you very much, sir.
yes, yes. So please join in the next class also. We'll be discussing about the next assignments. Sure?
Sure, sure. Yes. Yeah.
Yeah.
Thank you.
Sure, sure, sir.
Yes. Okay.